This is a short video showing an animation that you can use yourself by clicking on a link below the description that explains how displacement time graphs are created and understood. There'll be a very similar animation and description of a velocity time graph. The displacement time graphs allow us to visualize how objects are moving through space. And in this, we're going to explore some fundamental scenarios. A stationary object which is at different positions, objects at the origin point, and objects moving away from the origin. When you draw the graphs, there needs to be a vertical axis and a horizontal axis. The vertical axis will be measuring the displacement from the measuring point, and the horizontal axis measures time. To navigate between each page on the app, just click the Next button. First of all, we'll understand the very basics of motion in one direction and the importance of having your direction of motion, both positive and negative, identified very early on in the process. So here we've got a straight line that our object, a point, can move left or right. There is no other direction of motion. For example, I'm taking the center of the line to be where we're doing our measurement from. And S equals 0 means that the displacement of the starting point or the origin is at no displacement from itself. So any displacement is measured from this origin point. And also usually we start measuring time from this point. In this example, I'm saying that I'm measuring displacement and velocity from right to left as my positive direction. Then I'm saying that an object that sits on the line to the left of the origin is at a positive displacement. An object that sits to the right of the origin is at a negative displacement. And a velocity that's traveling from right to left in this situation has a positive velocity, even though its displacement is negative in this example. Now, in this situation, we've got an object whose displacement is positive, but it's not moving. So we say the object is stationary. In this example, we've still got a horizontal line on our graph, but it lies on the time axis. So its displacement value is 0. So the object is not moving, it's stationary because its displacement time line is horizontal. But in addition, it is at the measurement point or the origin. Here we've got an object that starts at time t equals 0, but it's not starting from the origin. It's starting at a positive displacement, and its displacement is getting larger and more positive, so it's moving away from the origin. In the fourth situation, we've got an object that starts at a positive displacement, is moving towards the origin, and then continues to move once it's past the origin. Where the line crosses the time axis is the moment at which the object is at the origin, and it continues to move to a negative displacement relative to the origin. And in the final example, we've got two objects starting either side of the origin. One has a positive displacement and one has a negative displacement. They both are moving towards the origin and they meet at point P. So the blue line shows an object starting at positive displacement and moving to a negative displacement. The purple line shows an object starting at negative displacement and moving to a positive displacement. The objects pass the origin, that's a displacement of 0, at different times, but meet at a positive displacement P, and then both objects keep moving away from point P. And that's the end of this introductory example of displacement time graphs.